Good morning, everybody. Welcome to this session on Niagara for gameplay for the Unreal Games Fellowship to 2024. So, in this class, we're going to spend the first few minutes going over some theory. So we're going to be looking at what Niagara is, talk, I think, a little bit about Cascade, which was the previous system that we were working with, which we still have a whole load of effects and still runs. And then we're going to do about three exercises. So the first one is going to be building a stylized explosion. This will be the longest, but the idea of this is we're going to be building a Niagara effect from scratch. So we will be sort of going through the whole process of creating an entire effect. Then the second two exercise, the second one is we're going to be connecting it to a projectile, just so that we can see a Niagara system in use. Really, that will be shorter. And finally, we'll be looking at the impact and creating a dissolve effect on the things that we shoot. Okay, so let's get going. So Niagara. So this is supposed to be Niagara is consistent of a lot of parts. And much like when we have an actor with components, with a Niagara system, we have it's almost a bit more like a timeline or a sequence. We have a number of things that are happening over a timeline, and they're being generated in quite a complicated manner. But it really needs to be thought of as a timeline. But to start with, we've got a few terms that are important to understand. The first one is a system. So a Niagara system, and you'll see that there is like a Niagara system actor that can be dragged into a world. And if you drag a Niagara effect into the world, it will by default, it'll think what you want is a system. So it will create a system, and that will allow us to play a Niagara system. Now, a system itself needs to have an emitter in order to do anything at all. And the emitter itself is just something which makes particles. Now, we can have multiple emitters within a system, and they can start and stop at different times, and they can be persistent, and they can have completely different behaviors. However, the emitter itself will not be seen. It is invisible. It is just a logic of how we generate particles. Now, below this, an emitter will generate particles, as you can see. So a system can have multiple emitters, and an emitter can have multiple particles, and most likely will. And I've shown three particles in each of these systems, but they very often are in the thousands and possibly even millions, depending on what you're looking on achieving. So it's just these are terms, because this and this coloring is going to become very important for us to understand how Niagara functions. Okay, now I think it's a good time for us to jump into the project. So again, I've fired up the project, and we will see from the project, hopefully you guys will have the training aid fired up. If you can, dock it in this top right-hand corner. It means, like interactive materials, we're going to be able to see that we're all at the same point, same time, so we don't get lost. And it will also help us navigate towards the different systems. So yeah, if anyone's having any trouble, please shout out. If you cannot find it, it is in the training tools directory, and you need to right-hand click and run editor widget on the training aid. Okay, or otherwise, I'm sure James or Lucas can help you out on that. Right, okay, so first up, let's have a look at the rendering op. Let's create a system to start with. So I'm going to talk us through the system. I think it's a good starting point. So I'm just going to create a dummy system. You don't need to follow along with this. It might be better if you watch at this point rather than get sort of confused, so that I can talk you through. Now, when you come into Niagara, you're often offered the option of starting from a template. Now, we have got a number of templates here, and you can see we've got a whole load of different things that can be done with it. And this allows us to start from a different point. You can get a whole load more of these if you want from the if you install some of the plugins. Like if you want fluid ones, for example, the plugin for fluids. So there's a couple of different plugins that are worth knowing about. So ones that are worth looking at is Cascade to Niagara Converter. This is useful because what it will do is it will our legacy system, our legacy particle system is called Cascade, and Cascade will it's still supported and will probably remain supported in the engine throughout 5 at least. However, what you might want to do is you might want to take an old effect and convert it into a Niagara effect, and this is a system to do that. Chaos Niagara, we already have that installed, but it allows us to generate secondary destruction effects. And there is also Niagara Fluids, and this will, if you click this on and restart it, it's going to give you a bunch of different, it will give you functionality for fluids, and it will also give you templates and starting points for Niagara. And we also have sim caching. This allows us to record how a Niagara effect plays in simulations like sequencer or tape recorder in order to play it back in the exact way. There is some functionality to do that within the systems themselves, but this will give you more templates to work with. Anyway, let's come back and we'll create a Niagara system again. So under FX, I am going to create a Niagara system, and it's going to offer me a bunch of options. I'm going to show you the fountain, but don't feel like you need to follow along at this point. This is just theory. I just want to talk through the different functionalities. So if I create a system, open it up, and drag this up here. I'm also going to change the editor open location to the main window, just so that it automatically docks at the top. Okay, so when I fire something up, this is what I get. So let's have a look at the interface. So the first thing we've got here over on the left is the viewport, and presently I can't see anything. Now, I'm not actually 100% sure. I've got a feeling this happened last time.
Yeah, I think it's a bug. You have to just untick and tick the emitter for the fountain. And if you press play now, you should be good. Or just untick it and tick it now while it's running. Oh, there you go. It was working. So if you look up a bit.
Yeah, there you
It's
go.
just, for some reason, it's bugged in 5.4, like the first time you load the emitter.
Okay, that's great. Okay, thank you. So what we have here is we have our beautiful fountain effect. Now, navigation in this is going to be the middle mouse button is going to take you in and out. If you hold down the middle mouse button, you're going to be able to pan around. Left mouse button's also going to let you zoom in and out. And right mouse button's going to allow you to rotate the view. Okay, now we will play with the backing, but I'll do that sort of slightly later on. But we cannot. So this is the basic viewpoint. This allows us to see what the explosion looks like. And by default, we have sort of a 3D sphere of headquarters to see it. Okay, so that is our viewport. Down below this, we have the parameters. Now we're going to be touching on these a bit as we go forward, but what they are is we can use, when we're creating our effect, we can use parameters as a means, as inputs to different modules on our effect. So a lot of these we don't need, but we can use them, and we'll go into that by far. But one of the things that we have here is something called user exposed, and this is going to allow us to make values which we can change programmatically, which we can then include within a Niagara effect. So this is like input variables, basically. And we'll do an example of that as we go further in, where we'll just create a value and drag it in and look into it. Okay, so these are the parameters. Next up, we have a systems overview. Now, if you remember the site, we have in blue here, we have the Niagara system as it is. And then in this kind of orangey brown over here, we have our emitter. Now we can duplicate this in. We could I just copy and paste it. So I can duplicate it just with Control D or all of the different elements, so I can have numerous emitters going. And now you can see it's just twice as intense. I just deleted it there. Now we'll go over this in detail because this requires some understanding. However, at the bottom, you will see we have our timeline. And the timeline is very important with it because with an effect, it is an animated effect, and what happens over time is very important to how this effect does look. So you can see that I can drag this back and forward, and I can see, and I can just stop, and I can view the effect at a certain point in time. Now, we can also zoom in and zoom out. I usually prefer to drag this down, but the green part is where the emitter is going. Now, this final part after this, actually, I'm not 100% sure how this works. It's still going, it's still producing stuff. So, yeah. Why does it stop being green? James,
So the green size that you see there is essentially relating to the lifetime that you give the emitter. So if you give the emitter a specific lifetime, which in this case is 2 seconds, that's how long that green bar will be. However, it's likely that this emitter also has essentially infinite loop set. So it's got a lifetime of 2, but it loops infinitely. So it just continues after. So that's why you're kind of seeing it like that. So yeah, you can see loop duration there is 2 seconds.
So if I was to turn off, just do it once, what we would see is when it hit that, it would stop generating them. But what's important to see is that the pixels don't immediately die unless you set yours up to immediately kill them. What it'll do is it will allow all of the pixels to finish their lifetime. So you can see here, this runs, then it stops, and it dies off. But yeah, so if I choose it to be looping behavior, infinite, we would just see it continue to go. All right, thanks, James. Okay, so now in the right-hand side here, we have the fountain, we have the details panel. And as you know, the details panel will be contextual to whatever you have selected at any one time. Now, what's good to know, what's useful to know, is if I select, say, that the Niagara system, I will get the details for every single node in the Niagara system. Same with the emitter. However, if I just select, say, spawn rate, it's just going to return me the options that are to do with spawn rate. Now we have, let's break down the emitter. So a couple of sort of usage things. You'll see that we have different sections and there's a plus, and this will allow us to add more modules. These are all little modules. Also, next to them, they have tick boxes, which will allow us, I'm just going to keep this playing, that will allow us to switch on and off the tick boxes. So for example, if I was to turn off gravity, it would compile and we'd see these things float off into the air. If I was to turn off add velocity, we'd see them just, only gravity would be the only effect that was working on them, and they'd just drop to the ground. So at any point, if you want to see what any of these nodules are doing, you can just switch them on and off quickly. If you want to add any in, you can push plus. And if you want to delete them, you can just right hand click and delete. Now, let us go over I think this is the most useful chart to understand how the system works. Now, we talked about it being a timeline defined. Now, if you look at this, what we have is we have starting off, we have an orange or a sort of, not quite orange, but I'll call it orange for simplicity. We have an orange section at the top, and that is about the emitter. Below that, we have the green section, and this is about the particles. Below that, we have a render section, and this is about what is being rendered to the screen. So, but each of these are also broken down into spawn and update. That's because when an emitter is initially spawned, this first section here, we can change the settings for the emitter creation. Now, secondly, we have emitter update. And so any nodes inside the spawn are only going to affect the emitter at the point of creation. And below this, we have emitter update. And the emitter update, this will happen over the lifetime of the emitter. So say, for example, we wanted to increase the spawn rate over the lifetime, then we could increase the number that it will spawn. So it starts off just spawning a couple, and then towards the end, it's spawning thousands a second. So, but this is time-based. So anything in the update, say it's over 10 seconds, what this emitter, how this is emitting will change. So you could change the color. So second 1, it creates red particles, and at second 10, it creates green particles. So the second, everything on the update is time-based. So this will change over the lifetime of the emitter. Now, second up, we have the particle spawn. So this is going to be settings that happen at the point of spawning. So you could see with the two examples that I gave, the ticking the boxes on and off, I had initial velocity that fired them up in the air. Now that was something that we did at the point that it was spawned. We gave it a velocity going up. Now we're not changing that velocity, and we're not doing that consistently over time. We're just giving them that velocity at the starting point. So that's an example of something that you would place on the particle at the point of spawning. Now, after that, we had particle update. And a good example of that was gravity. So we had gravity, which was continuously acting on the particle over its lifetime. So as it shot up, the The gravity brought it back down. But this again could be used like in colors. Over the lifetime of a particle, you could start it off as red and then change the color at the end to green. So these are really important, knowing where you're looking at changing settings, because you want to know, is it on the emitter or is it on the particle? And is it at the point of spawn, or is it something that's changing over the lifetime of the particle, of the element? Finally, we have the render. So the render is what we are actively rendering to the screen. Now, let's have a look at what our rendering options are. So, for example, if I was to push this, I've got a number of different choices of what I could render. Now, let's have a look. So if I jump onto the second thing and push G, you know what? I'm going to drag down the works. So the first thing that we have an option of is a sprite render. And what a sprite renderer is doing is it generating a small plane. So if I was to, I think I can see this in wireframe. Yeah, there you go. So you can see here, this is generating a small plane, which doesn't necessarily have to face the camera, depending on your settings, but it's generating a small plane which has a sprite rendered upon it. Okay, I'll just turn it back on. So our next option for render is a mesh render. In this time, we're just using cubes, but we can render out a mesh, and it can drop down yeah, these, as you can see, both of these are exactly the same effect. The only difference here is in this one I've selected the sprite renderer, and in this one I've selected a mesh renderer. The particles themselves are unaware of what they're rendering. They are the behavior is all denoted before it goes away and renders it. So I could turn this is slightly different because I put a collision to make it bounce where I haven't on the sprite render. Okay, finally, not finally. So next up, we have the ribbon render. And I find this a little bit harder to make it work well. But I've seen James do great things with it. But what it does is it draws a line between one spot and another. So as you can see where the particles here are, I've lowered the number, or otherwise it just looks like a mad squiggle. But the render itself is drawing this ribbon between the particle and the next particle which comes out. Next up, we have a light render. And you have to turn this up really high to be able to get something that's demonstrating. But again, what we're doing in this situation is we have a very similar fountain to all of the other ones, but we are just rendering a light on each one of a randomized color on each of the particles. So it creates this kind of nice droplet effect. So, and the last one we have is a decal render. Now, if you know what a decal is, it's just a texture which is projected onto the surfaces which are around it. And that's what we're doing here. We're just randomly projecting the green face against the wall, but it's generated in a particle system. This can work really well. I've seen it work really well with like creating paint splodges on the ground or something like that. So it's an interesting tool. Okay, so those are our rendering options. There are a couple more, but there are fluids and stuff, but those are the basic ones. Okay, so also with any effect that we are working with, we have a option to render it either in local space or global space. I'll show you the settings. Now this shows you how differently that works. So this is the same fountain, except for one of them is working. The one on the left is in global space, and the one on the right is in local space. So you can see how differently that would vary the effect that you're creating. Okay, so now will be a good time for us to jump into the exercise, but let's check if there's any questions or confusion at this point. How are we doing?
So far so good.
Okay,
So we're good to keep going.
let's go then. Let's make our stylized explosion. So if you're over on exercise 3, hopefully you're in the exercise 1 directory. Now I'm going to right hand click, and under FX I'm going to come down and I'm going to create a new Niagara system. And when I get the templates to work from, I'm going to ask you to work from the empty template. This allows us to create everything from scratch. So I'll select empty, and I am going to call this system ms underscore impact. So NS for no, it should be NS. So it's for Niagara system. Yeah, it's complaining about something there. I'll go with MS for the time being. But it's up to you as long as you know what it is. Okay, and let's open that up. Okay, so we have our NS impact, we have our MT. Now, the first thing I'd like to do is I'm not a big fan of the backdrop here. I find it can be useful, but for most cases, I really just want to see my effect against a black screen in a lot of cases. So I'm going to change this. And I recommend you do too. So to do this, what you'll need to do is come up to Windows. And under Windows, we have preview scene settings. So this is what will allow us to change it. I'm just going to jump in, and you'll see that preview scene settings jumps up on the right hand side here. And under the environment, I'm just going to drop down. I'm just going to mute you, James, just getting some ticks.
Oh, sorry.
No problem. Yeah. Okay, so we have show environment. So the first thing I'm going to do is I'm going to untick the show environment. So we get this lovely default gray, which makes sense to me, but I'm going to take that gray and I'm going to make it black. So this means that we've just got a black backdrop and our effect's going to be considerably easier to see. Okay, right. So again, how I've done that is under Windows. I have ticked on the preview scene settings. With the preview scene settings in the top right-hand corner here, I've unticked show environment, and I've changed the environment color to black. Okay. So I'm going to go back to my details panel, so I'm going to need that. I'm going to select the emitter that comes here by default. I'm going to right-hand click, and I'm going to rename it. I'm going to call this Sparks, because we're going to be creating an impact effect, and I want to I'm also going to reduce down the size of this so that it loops at a tighter duration so I can see it more. We're going to be creating numerous sections to this. The first thing I want to create is sparks. So now to start off with, I am going to come under the state. No, I think I'm going to add. So let's see. I'm going to add under emitter update. I am going to search for burst. And I'm going to select spawn burst instantaneous. So now we have a dot in our system. And I'm going to change the settings of how I want this to burst. Now, I am going to change this to 100. So we have 100 bursting. And I'm going to leave the spawn time to at 1, but I could move it across. I could make it in 1 second in. So then it would all appear at 1. So you can see that's the reason why it's actually on the update, because we have options to change when this spark happens. Okay, so this is our first node. You can see we can turn this off and turn this on, but it spawns particles in a burst at the specific time. There's one other setting that at the moment you can see under properties here, it says CPU. Now, if I select all of this, you can see at the top, I've got a couple of options here. And one of them, the simulation target CPU or GPU. Now, there are a couple of reasons why you want to split between these. It could be an optimization thing, but usually I'm going to jump onto the GPU for this one because the GPU is using a dynamic bounds, so it's using a dynamic bounds. That's all good. I'm happy with that, but it will now run on the GPU, which is slightly less well. CPUs are fast, but there's few of them, and they do stuff one after another. GPUs can run millions of things in parallel, and particle systems are a great option for a GPU. Okay, so next up, under the particle spawn, select the initialize particles. And for this, so this is our initialized particles. This is where we get to set up all of the beginning settings for our particle. Now, the first thing at the moment with the lifetime mode, you can see that we have this to a direct set. So that means we are going to, all of these particles will live for 5 seconds. Now, we're trying to make sparks. So if you can imagine, if we have a fire, when you get those little sparks that come off and fly off into the wind, that's the effect that we're looking to create with this. So 5 seconds is too long, and it is also too consistent. So rather than direct set under initialize particle, I am going to choose random. And as soon as I change this to random, I am going to be given some options here of lifetime min and lifetime max. So I would like you to set this to 0.3 and 0.8. Now, there's a lot of feeding stuff in this example, and it would be good if you follow along, because at that point you'll get some more experience hands-on with playing with the effect. However, if you want to watch, the other examples are slightly smaller, and you can see there is a finished version. There should be a finished version here. So if at any point you want to check, you can see that we have the final effect here finished. We're building. And so if you ever want to go in and check if you've got any of your settings wrong or something like that, you can always jump in and grab and just look at that. So try and plug that in over there on the right so that we can do it. Okay, back to our impact. So our path, we're doing the path initialize particles. So the first thing is the lifetime mode. So we changed it to random. Again, this is a little bit hard to see. but it just fades out a little bit more random. Now, the next thing that we have here is color. Now, the color is unset, and that's why we're getting just a white at this point. However, let's do a direct set. And that's going to give us this option. So sparks down, it's there. Now, we want to change this, and what I'd like you to do is change this so that the red is at 300, the blue is at 0. You can see that gives us this kind of sort of red emissive color because it's so high at this point. You've got this beaming red output at this. So we've got the color, mass mode. You need to change the mass mode. Yeah, okay, so under the mass mode, I'm also going to change this to random. So as soon as we do physics simulations with stuff, gravity is going to affect and calculate how these elements move. However, if we come into mass and we change it to a random, and let's change it from 1 to 2. Now, we're not going to see this effect because we haven't turned on gravity at this point at all. But what this will allow us to do is this is going to allow us to have gravity affect different particles in a different way. So, and finally, the sprite attribute mode. Sprite attribute mode. Let's change this to random uniform. So we have, we're going to change it random uniform between 6 and 10. So now we're going to get different sized sprites. And it's not going to be too apparent until we actually get these things moving. Now, I'll drag up this just in case you are following along so that we can present it. These, again, the notes will be really useful here because it has breakdown of node by node of what I'm changing in order to do this. Okay. So hopefully you've got initialized particle. So let's add some velocity. So we're going to add a couple of things here. And this is under particle spawn again. So under particle spawn, I'm going to push add next to this. And I would like you to add in 2. I'd like you to add a shape location. And I want you to add a velocity. I think this is a really useful way of learning Niagara by building it up node by node, because you can see what every single node does at this point. So we have now, so we've got 2 elements. Let's start with the shape location. Now we're already generating stuff in a sphere. So that's fine, but we're going to need to change some of the settings for it. First thing I'd like to change is the radius of the sphere and make it just 80. So we're just bringing the sphere in slightly. Now, the second thing that I'd like to change is we're fine with random, but I would like to change the hemisphere distribution. So as you can see that we have a sphere now, I'm just going to drag that there so we can just see we've got a sphere like this. Now, with an explosion, I don't really want the bottom half. Say this hit the floor. I don't want to be generating the particles on the floor. Or if I hit a wall, I would just rotate it to face a different direction. So I only want it in one hemisphere. So in order to do that, I've got a hemisphere distribution, and I'm just going to change the second value to 0.1. And so now you can see that we're only generating the particles on the top half of the sphere. So as I cycle through it, yeah, we're just generating. Okay, so that gives us, so again, the two settings are, I'll flash up the after I've done them, I'll flash up the slides again. Now, the next thing that we're looking at is velocity. Now, so velocity is we're adding movement to this, or at least an initial velocity. Now, as you can see here, when we come up, we've got a red dot and we've got some problems. It's saying the velocity has a number of dependencies. There are other nodes that are required in order to add velocity to a system, which we have not got. However, what's useful is there's a couple of buttons that says fix issues. So if you push either one of them, it's going to add in the solve forces and velocity so that we can get this to work. So it's a nice quick fix. However, now I'm going to go back to add velocity. The velocity mode, I want to change from linear to from point. So if I was doing linear, I could just send them all up. But now it's going to be the velocity away from a point. And now it's asking me for a velocity speed. Now, I don't have an option for randomness. And that brings us on to one of the other sort of underpinning methods of how Niagara works. You can see on the right side of this node, I have a drop down. Now, this is very common. So you'll be able to see it all over the place for different elements. And that's because this drop down is going to allow me to change the input. Now, it's going to allow me a lot of different ways to change the input. For example, it would allow me to bind or plug in one of these values in the bottom left-hand corner in the parameters into it. So say I wanted age, for example. You can see I have the emitter age, or the particle age, or the stack content age, or the age engine system age. So there's a whole load of settings that I could get from that. Or if I had created a user exposed variable, I could connect that variable up to this. Now, what I'm actually going to use is one of the suggested ones. I'm going to use random range float. So when I create that, this is very similar to what we had before. We have a minimum value and a maximum value, and it will generate a random value between the two of them. So I'm going to start off with the minimum value of 500 and the maximum value of 700. Yeah. And so now you can see that we have an effect where we have an explosion, a random explosion of velocity of the elements heading off in multiple directions. So it's a really, yeah, so, and you can see here, this velocity origin, this is already bound to simulation position. So you get more used to how these bindings work as you go through something, but it's just a really important thing to know that you can take any of these inputs and you can bind them to different outputs, or you can just change the way it's calculated.
Ed, could you just go through that random range again, how you set it up?
No problem. I'll just convert that back. So what I did under velocity speed is on the right-hand side here, there is a drop down. And from that drop down, it's going to give me a lot of options. And the one that I'm looking for is I want a float in a random range. So you can see that we have an option for random range float. And as soon as I select that, it gives me an input and an output. And I'm going to change the minimum to 500 and the maximum of 700. So every single particle is now getting a random value between these two inputs, giving us this explosive effect here. And so just to clarify, the settings which I've changed are these. So on shape location, I've changed the sphere to 80, and the hemisphere, I've changed it to 0.5. So it's hang on. And then from points, I've changed it to a random range float with the value between 500 and 700. Okay. Right, think I'm good to move on?
Yeah, you should be good.
Sweet. Okay, so let's add in some force to make this thing a little bit more interesting in its explosion. So what I'm going to do, and I want these forces to work as the particle updates. So again, we've added a velocity at the beginning when we first created the particle, and now we want to do something over the lifetime of the particle. So I'm going to add in two nodes. The first node is the curl noise force. And the next node is a gravity force. Okay, and just creating them, they're acting slightly differently here. However, I do want to change some of the settings. So the gravity I'm going to reduce. So standard gravity in the so real gravity is about minus 980 per second. I'm going to change that to minus 300 so that these float a bit more. They have some gravity, but they're not as much. And I'm going to increase the curl noise force. I'm going to increase the noise strength to 10,000. So now you can see that we've got that kind of effect that is, we got the kind of effect where it's getting blown by the wind. Okay, so to clarify, the changes I made there are these. How are we doing for time? We'll have a break kind of on the hour. Well, a little bit after, we'll just finish. What should we, after we finish this effect, we'll have a break.
We're close now.
Pardon?
We're close now.
Yeah, we're not too effect. We got, and as you get used to it, we can go faster through it as well. Okay, so next up, I think this is an interesting one. I'm going to change the color of the particles as they move. So under the particle update, I'm going to do plus, and I am going to search for scale color. And so in our setup for scale color, the first thing is we have the RGB and alpha separately. So if you work with colors, RGB is going to be the color, and the alpha, depending on your material setup, is usually going to be the opacity. So we are going to change these separately. So the first thing I'm going to do is I think I'm going to untick the RGB. I don't think we're changing the color, are we? We don't need that one. Okay, we've set it at the beginning, so I'm not going to change the color again here. However, I am going to change the alpha. Now, at the moment, the alpha is set to 1, but I want to change this over time. I want the alpha to fade out as we get to the end of the lifeline of the particle. So in order to do this, again, I'm going to do a drop down. This time I'm going to use a curve. So if I take curve, you'll see that I have the option of float from curve. So much like when we're working with a timeline, we outputted a float. This is going to be the same thing. We're going to have we're going to be able to control this alpha using a curve. So again, on the drop down, I've got a float from curve. Now you can see what this is doing is as it starts, we're starting with 1, and we're ending with 0. So that means this is going to fade over the lifetime. And this is the lifetime of the emitter. So 0 is when the particle first exists, and 1 is at the end of its life. So this isn't time, this is the length of life that each particle has. Now, the only thing I'm going to do is I'm going to drag up of these and right-hand click just so that I can use auto. And that gives us a little bit more control. That gives us a little bit more of a smoother curve at this point. So the curves are very useful in particle effects because they do allow you to change things over time. And we'll play with a couple of other options that you've got there. But yeah, just like timelines, this would be your curve over time. So it's a bit hard to see, but they are getting dimmer as they get further away, like a spark does. It starts off with a lot of energy, but at the end of it, it just peters out. Again, I'm going to drag that up, but present that, show that on the screen a second. Okay, so hopefully everyone's got that working. Next up, what we want to do is we want to give them a more natural shape. So now at the moment they're circular and they look all right, but it would be better if they had a different shape. I'll show you. So under plus, what I'm going to now search for is scale sprite by speed. Scale size by speed. You can see it. No, we're looking for sprite size by speed. Scale sprite size by speed. Okay. Now, we have a couple of options here. So the first thing we're going to do is the minimum scale factor we're going to keep as 1. The maximum scale factor, we're going to change this to 0.1, 3.3. Now, what's interesting is you'll now see that rather than being a spot, we now have little lines which are all facing up. Now, we also want to, under this, we've got an option to sample scale factor by curve. We're going to select that on, and that should be fine. So now it looks like we've kind of wrecked this a bit. And that's because what we need to do is we need to change something in the sprite. We need to change something, I believe, in the sprite render. And what we need to do is we need to change the alignment, because at the moment it's keeping the same alignment throughout. But if I come under alignment and select velocity aligned, then you should get an effect which looks a bit like this. So now that improves it a lot. So we've got it kind of creates the effect of a tail just by aligning them to the velocity. So again, and this is the two things that we did here was we put in a scale sprite by speed, and we changed the settings so that we kept the minimum as 1.1 and the maximum as 0.1 and 3.3. The velocity threshold, I don't think we changed. We ticked the button to sample scale factor by curve, and then we've made this increase over time. So they get longer as they move further away. And then the final setting was under sprite render. On the alignment, I made it velocity aligned. So that's the start of our effect. I think that is a logical place to take a break. Is there any questions, any people specifically stuck before we go on? I'm going to build the second half of this when we come back. But okay. Unless there's any other questions that we can carry on to the second second emitter. Okay. Oh, I'm sorry, this is taking longer than okay, so let's try and make the second emitter then. I'm recording, yeah, let's go. So we've got our first emitter, that's our sparks. I'm hoping the second one's going to be a bit faster. So first thing I'm going to do is right hand click and I'm going to add an emitter. I'm going to add an empty emitter because we're starting from a point, and I'm going to rename this to emitter to streak shapes. So if you could rename it to streak shapes. Okay, and again, what should we leave this on GPU? We can leave this on CPU. Well, that's what we've got in the example. Okay, so let's jump down to the. Maybe we just copied the last one. No, we didn't. Okay. So we've got streak shapes. Yeah. Now we have two emitters. The first thing we want to do is the emitter update. And for this, I would like you to add in a emitter state, an emitter state, and a spawn burst instantaneous. Okay. For the emitter state, under the life cycle, rather than it being the system life cycle, we're going to go to self. And so this can be sort of separated from the system in general. And we're going to change this to once. So on the previous one, I think the other one was, I think it was once. What was the, is this defined by the system? This we're going to define by, we're going to make it once. And that's the only setting that we'll need you to change there, I think. And on the spawn burst instantaneous, let's make this 15. Again, we'll start at 0. So those are the only two settings that we need at that point. So let's grab that up and paste that up. So we're adding in the emitter state, self and once, and the spawn based instantaneous. And we want 15 of these. Okay. Next up, let's initialize the spawn. We're going a little bit faster these times. If you're having trouble keeping up, we have everything in there, but I just want to make sure you guys have understood the system. Okay, so spawn, particle spawns. So what I'll do is I'll push the plus, and I am looking for initialize particle. Initialize particle, shape location, and add velocity. So very similar to what we were doing before. We'll go through these. So for the initialize particle, now this is the slightly longer one. So the lifetime mode, again, we want this to be random. So we're going to come in here and we're going to do random instead of a direct set. And we're going to make it between 0.15 and 0.65. Now the color mode, direct set is fine. We're gonna work on the same. We're gonna look at the same colors as this one. So just 1 second. So color mode. So, and that is 300 on the red. So we get that nice emissive effect. And 1 on the green and 0 on the blue. And alpha 1. And under sprites attribute, the sprite size we want to be random non-uniform. So again, this will give us a min and max on both of these categories, but we are going to do it as 20, 100, 50, 200. Okay, so these are going to be quite big sprites compared to what we previously had here. Now I'll jump onto shape location. And under shape location, we're fine with sphere. We're going to change the radius to be slightly smaller to 80. The sphere distribution again is going to be random. To see this, one of the things I'm going to do is I'm going to turn off these sparks, because this will at least let us see what we're working with at this point. Now we got some errors, so because we've got add velocity, so we can't see anything at this point. But let's go through and change these. So again, I'm going to change the hemisphere distribution so it's only on the top half. I'll bring up the screenshot from the slides in a second. Finally, we have add velocity. And again, we have this complaint that we are missing some nodes. But it's quickly fixed by hitting the fixed issue button. And now if I hit play on this, I'm going to reduce the length here. If I hit play, no, we see nothing. Looks like we've got one error. All right, I'll go through the rest of the settings. So velocity, and we want this to be from point rather than linear. And the velocity speed, we want to make this random again, but we don't have an option for random. So we're going to have to do the drop down and search for a random float in range. And I'm going to change that value to 200 to 300. Now I have an error. Warning, emitter uses dynamic bounds, but only emitting source renders. Please update the emitter system process, otherwise bounds may be incorrect. So it looks like we've got a problem with our bounds. So if I jump up, we can see that we're using the dynamic bounds. I might change this to fixed, and that should fix it. The problem with the fixed bounds is it's going to change the size. So let me see how that looks. Doesn't look at all. In the sparks, we've got a similar problem. Does not like dynamic bounds. So just turn this on. Going to change that to fixed. Turn that off. Oh, we're not seeing anything because we haven't had anything into the render, but at least we don't have any errors. So we will fix that in a minute. Right, so to clarify, these were the elements that I've changed. And I've also changed to fixed bounds. So we have the streak shapes. Next up, let's do let's add a sprite render so we can actually see this thing. So I think that's the next one. Done the initialized particle. Yep, sprite render. Okay, so at the bottom here, we can see there's a button for a sprite render. And again, we're going to use the sprite render. I'm going to use the sprite render up to this point, but we have our spheres and they are elongated. So what we're going to do is we're going to change a couple of settings. First one is the material. Now we haven't really touched on the material, but materials are important when you're using effects, because not everything is a sphere or a form of sort of a molded sphere. So we have another. I'll quickly look at this particle system because I think there are a couple of things that are worth looking. And the main one I would say is the particle color, because you can see that this is an input pin. The type of material is additive in this case, so that if we have lots and lots of sprites on top of each other, they get brighter. The shading model is unlit, surface domain, but we have, so the blend mode is additive. Here we have the particle color, and this is where we're getting the data from the color and the alpha into the material. So if you don't have this setting within the material that you're working with, you're probably not going to see the effects that you get from the whatever you're generating. So yeah, there's not a huge amount of other things here, but the particles color is the big input to the material. Okay, so I do not want to say that. Let's open up. Let's change the material over. And the material we'd like to use is the material instance impact shapes. So as you can see here, we've now got these spikes that are going up. Now, we're going to make a couple of other changes here while we're here. So we're okay with particles. The alignment, again, we're going to go with velocity aligned. So our spikes are sticking out in the direction that they come out. Now, the other thing, if we were to open up this material, place it on a cube, you would see that we have four different spikes at this point. And we don't want to see all four of them. At any one time, we only want to see one, and we want to use that in order to denote it. So what we're going to do in the impact, what we're going to do in the system is we're going to come down to the sub UV. And we're going to tell the image that it has 4, and only 4 across and only 1 up. So now we have just one spike. Also under cutout, where's cutout? Under the cutout, we will go use cutout texture. And I think that's it. Okay, so let's go from that then. Right, so now you see we've got the spikes that are shooting out. The next thing we want to do is we want to randomize the UV settings, because we only want to show one, but we want to show a different one each time. So we need to do this on the particle spawn. So we don't want this to change. This isn't going to be a flip book. We just want to pick one at random. So I'm going to push plus, and I'm going to search for sub UV animation. And I'm going to add that in. And rather than it being linear, I'm going to make it random. Render type sprite. And sprite render. Okay, and we are going to tick on the end and the start frames. Now it thinks there's 63, but there's only 3, so I'm going to put it at 3. Okay, so now if I turn back on my think, so we've got the randomize. So, and there'll be one last thing to do before this effect is finished. And that is under in the particle update. So I'm going to come down to the particle update, and I'm going to add in 2 more nodes. One of them is going to be particle state. And the next one is going to be scale color. Now, particle state, we don't need to update anything. We're just going to leave that as it is. However, under the scale color, I'm happy with this being 111. I just want to fade them out like we did the other one. So under the scale alpha, I'm going to do a drop down and I'm going to type in curve from float from curve. Oops. See. So, and then I'm going to drag these up, right hand click, and just set them to auto. So we've got a bit of a smoother curve. So I'll put this up, and this is the last thing I'm going to be asking you guys to do. In the last exercise, I might ask you to plug in something, but okay. So if you've done all of that, turn back on the sparks, hit play, and you should see we have our impact. So if I drag that into the level, you're going to see that it creates a Niagara actor, and I can force it to reset and just play it inside the level. It's probably the easiest way to see it. So hopefully your effect, yeah, looks something like this. Okay, any questions? I don't really want to we got a lab for an hour afterwards, so if people are generally stuck, we can go back over it. But there is the finished version if you want to check it out in the finished drive. But we have almost half an hour left, so I'd like to push on. Is there any major issues or questions in the chat?
Some people sparked emit with a delay, but that's probably going to be down to spawn time or your emitter delay. You just select your emitter and check for the delay itself.
Yeah, so there is a
Yeah, spawn time 0 is probably what you want at the sparks.
spawn time 0. Yeah, so if you move it into 2 seconds, it will. I think if you also grab one of these and just move it, you can't just move it, can you? No. You have to change what's his name? What was the initialized particles, the add velocity, spawn burst instantaneous? If you change the spawn time here, that's going to change when they start. Same for the streaks. And yeah, so the emitter itself, no spawn time, doesn't have any settings. Yeah. Anyway, what I think I'll do is I'll move on at this point.
You can move on. Like we've got a lab, we can catch all of these after that.
I think as long as you've sort of understood it, I know that seemed like a bit of a long one, but I kind of feel that there's no way to get started with Niagara without building a Niagara sort of step by step. It is. So now I'm gonna talk about, well, now we have exercise 2, and I'm not going to ask you to follow along with this one, even though it's relatively sort of straightforward. It's just if we want to go over it or put something together, we will in the lab or we will have it in the recording. But what I wanted to talk about was how to create a projectile. So in this instance, what we have is just a system here which is just shooting. So it's just shooting out different projectiles at periods of time. So we have the dummy projectile here. I'll open this up. Just close this down. So just close down all of these systems. So it's really quite straightforward in this. What it does is it waits 2 seconds in the projectile and then kills itself. So just so that we don't have too many of them hanging around. Now, we also have a system here, which in the middle allows me to, if I control E and open that up, what's this doing? Okay, so what I'll go through the steps as it said here. So we've got a projectile. So I'm going to open this up and I'm going to change this projectile so that the effect is being used on it. And so this is very similar to any of the projectile components that you'll see if you use the first person mode with the gun or anything like that. It's going to be the same. But the first thing I'm going to do is, so we have the only thing that we need to make it a projectile is the projectile movement. And that's already set up with 700 to 1000, and it's useful if we've got a collision so we can make it do stuff. Oh no, so this is the end product. So we've added that in. Now, in order to get this to work, all I've done is added a Niagara system to the projectile. So if I was to delete that, I just go add. I can add a Niagara system in. I'm going to child it to the collision, and I think it's under trail. So we have fire trail, and this looks like that. Now this looks too large, so I'm going to change the scale down to what I think was about 0.2, 0.2, 0.2. So now we have our particle system. And this is a slightly different particle system. Let's open it up and have a quick look at it. So James has done a great job of commenting the whole thing here. But we have a number of fire trails. So these are ribbon renderers, as you can see. You can't see these until we turn on the add velocity, because was it the add velocity you were using to imitate it? No, I don't think so. But trust
It
me.
should be. I think the black background might be
So
what's making it tricky to see, but
we'll see these coming out, but they add a ribbon they add a ribbon out of the back of it. So we've got a trail. And then again, we've got our sparks, and we've got this section here is quite interesting because we're not using a mesh as part of the projectile. We are using Niagara to create this. Now you can see what this is doing is this is creating a singular spawn, and it is and it's set to live infinite, so for the whole life cycle. And under this we have the SM_ projectile. I open that up. You can see it is so half of this is the mesh and the material that's placed onto it. So again, with the material, you can see that we have the particle color being plugged in. So this is very much like we were doing before. We've got a couple of other we're animating this using the same texture, and James can do a bigger breakdown in the lab if you guys are interested. But it's basically an animated material on a mesh shaped like a projectile. So that's the creation of it. And if I now compile, and now what I need to do is I need to swap over the meshes that are being fired. So I'll just simulate. So, oh, I've locked this, that's why. Okay, so I'm just going to change over the projectile so we can see this thing running. Now, you can see that we've got the trails that are coming, the ribbon effects coming behind it, and we got the sparks that are coming out of it. The keen-eyed among you might have noticed that the projectile is facing in completely the wrong direction. Now, I was going to use this to demonstrate something because I'm not sure it's the best demonstration. So there are a number of ways to fix this. So the first thing is it can be very, very quickly fixed inside the projectile movement. If we look at the projectile movement, there is an option for rotation follows velocity. And then if we hit compile, you'll see that it has fixed the problem. So that's rotating the actor itself. However, and this is what I'm just going to show you guys in the slides. What you could do is we could also we could expose a user variable, the velocity rotation. And then when we have in the mesh update, we could orientate it to a vector. So once we've created this variable in the user, we can then use it as the facing direction. At that point, I could programmatically on tick here, change the velocity rotation. And I'll do it. This is quick enough. No, I won't. So what we're doing in this situation is I just wanted to show you an example of this is the node that you would use, set vector parameter, with a reference to the Niagara system in order to update a user value, which can then affect how the particle changes. So I'll talk you through that quickly just so that you understand. So if this was turned off, so rotation follows velocity, on the event graph, what I could do is I could grab the first thing I need to do is under the trails, I would need to create a user exposed. And I've got one here, velocity rotation. Now, I need to add in a setting under the update mesh orientation. So update mesh orientation. I am already got it here. I am rotating to the velocity rotation here. Now, inside my projectile, I need to calculate the velocity and get the rotation. So I need the Niagara system first. So drag in the Niagara system, set vector parameter, plug that in. Then I am going to get the velocity and get actor rotation. And I am going to make rot. Make rot from X. And I'm going to invert. So invert the rotator, combine the two of these. So it's a bit difficult to sort of figure out, but what we're doing is we're figuring out the relative change in rotation which would be required in order to get it in there. I'm going to plug that in and change the value to velocity rotation. Now, I'd like to rewrite this because I don't think this is the best example. I think just changing a color, just setting a color so that if you have red guys, they shoot red stuff, and if you have blue guys, they shoot blue stuff. That would have been a far simpler sort of example. But that should now, if I run, see, it would do exactly the same thing, but it's vastly more complicated. So, but it's just an example of how you can control a Niagara from coding. Okay. I'll jump onto the final example. And that is a dissolve effect. So in this level, we have a number of manis in different states of calm or anger. So it gives us just a sort of shooting gallery, really. So I wanted to finish off with something that might sort of be much more sort of appropriate to a game. So what I would like to do is get you guys to go through this. So if I was to now run the game, so if I jump in, you can see that we have our effect. So that should run if you fire it up. And that is the combination of what we've been working with up to this point. But we have a dissolve effect. So I want to go over and show you how this dissolve effect is working in the simplest sort of way possible. So we have our projectile. Now, our projectile works very similar to the previous projectile that we were working on. We have projectile movement, we're rotating to follow velocity, and we got all of the other elements working. However, this is our beginning section. And we're only doing this once because I don't want this to play through, but this is only on the hit. So once our projectile has hit something, what it will do is it will play a sound. So it will play an explosion. What I could probably do is spawn, what I probably should do is spawn the explosion that the Niagara effect we've already created. But it's going to play the sound and then it will destroy the component for Niagara because I just want to hide this before I move on. Now I'm going to cast to the character to check if it's actually hit a character. And if it has, I am going to add the Niagara particle system component and then set the visibility on the mesh to nothing. So we're doing this all within the element. So we're creating it and we're attaching it. Well, let's have a look at this effect. It's quite a straightforward effect. And if we watch it here, you can see that it's just an explosion. And it's designed to be, this would be easier to see if we have a background. So environment, show environment. So we can see it starts off red and then it turns black. So how we're doing that is we are just changing the color over time. So color. Spawn instantaneous, add velocity, collisions. I'm not sure where we're doing the color. Anyway, the most important bit that I want you guys to look at here is the location. Now, we are not actually using we're not using a sphere like we did previously. We are using the skeletal mesh location. So what's interesting about this is when I go away and I attach from the projectile, when I attach this to a character, it's going, or another actor, it's going to look for a skeletal mesh. And at the point that it finds a skeletal mesh, it's going to use that. And in this case, based on the triangles, it's going to use this in order. So if I change the preview mesh, just for example, it sort of explodes too fast. But it's going to use that in order to figure out where to start the particles. So it will destroy, it creates them at the vent and then fires them all out. So the effect that I was going for, I'll play it again just to you can have a go at it, but the effect that I was attempting to go for was that they were vaporizing into black dust. Now, I didn't want to make it too complicated since we've gone through multiple effects, but the nice thing about it is none of the code is on the characters that are moving through. I can do it all from the projectile. So it's just one way of working with this. So yeah, and I'm changing the visibility. I'm not actually destroying the characters at any point here, but I'm setting the visibility on the character to be just not visible, to give it the effect of disappearing. So yeah, there are other things that I could do at the point of hit. I could probably spawn an explosion actor as well. So we could spawn. So if I go Niagara, so spawn Niagara emitter at location or attached. So I could use this in order to take our that's Cascade, I think. Sometimes you get confusing ones with Cascade, but Niagara. Try spawn Niagara. Spawn system at location. And if I go for we have input, impact, finished. So we'll go for impact finished. And I'll do that. I'll do the do once first, just so that we don't spawn it multiple times. And so I could have grab the hit location. Probably should change the rotation just for the point this hits, but then this is going to spawn that effect at the location. So hopefully this works. Play around with that. I probably want to make it smaller. Projectile. So we're going to make the scale 0.3. And I could get the hit normals to make rot from Z. Let's see how that works. Still make that smaller. And so get rid of these. Yeah, so I make the systems as small as I can make it. Auto destroy.
Scaling particle systems can be tricky because you can scale the system, but the particles have already spawned with their own kind of world space value. So if you're not using local space, scaling the particle system directly from there is always going to be a little bit tricky.
Right. Okay, that's interesting.
So that's why the scale is kind of not directly working. It's not very intuitive, but that's just a heads up for people.
Yeah, no, that's good. I realize I go on for hours just making it smaller and smaller and smaller. Right. Okay. So I think that's sort of a logical point to think. So what we're hoping to get from this is you can see the different uses and how you can tie Niagara effects to things. So, and projectiles are really the best one. So we've got the spawner system at location. That's gonna create a system in itself that runs. And if you have auto destroy, when it gets to the end of it, it will automatically destroy. So that's how I've spawned the explosion. The Niagara system that's attached as a component, which is going to sit and just hang on to it. So I've often used this as like, if I do cars and I do a big engine, I'd have steam coming out of the exhaust pipe or something in world space, or kind of something on fire or something. The dissolve is an effect which can be is generated where I have attached it to a different actor or off the back of it just to generate this type of effect. But the interesting thing about it is it's using the skeleton. So you can see that you could create different effects, or like I could easily create a Niagara effect, which just created black dust, which was sort of emanating off of a character. And so, but it would come from the actual mesh. So it would always be using the mesh as its starting points. Yeah. So hopefully, you know, I've got a good idea of how to create a system, how to see what a system does, and how to add it and include it within your game. I mean, the other thing that we haven't mentioned is you can just drag them into the world. So, for example, in the starter packs, there's pretty much always a fire, which you can just drag into the world like that. And then that will just be an actor among itself, which just plays continuously, much like if you would have spawned an effect. So I will fire it up, but we won't really start talking about Niagara until then. So take a break, everybody.
Thanks, Ed.
Well done. Okay.